Section 5.4, the triangle mid-segment theorem. This is the objective. Prove and use properties of triangle mid-segments. Vocabulary is mid-segment of a triangle. Next slide. Let me read this. A mid-segment of a triangle is a segment that joins the midpoints of two sides of the triangle. Every triangle has three mid-segments which form the mid-segment triangle. Look at this illustration. This is what this is talking about. Here we go. So you have side PQ, which is the side of a triangle. This is the midpoint. In the same manner, you have side QR. This is the midpoint. If you join these 2 points with a segment, this is what we call the mid-segment of a triangle. And again, every triangle has 3 mid-segments. How do we generate this mid-segment? Well, you already have this midpoint. How do we come up with this midpoint? Just find the midpoint of PR, which is, we're calling it Z, and then that's how we end up with this. In the same manner, just join these 2, and that's how you come up with the mid-segment triangle, which is what is here. Let's move on to the next slide, and we'll talk about some properties of mid-segments. Triangle mid-segment theorem. You can read this, but let me just highlight what this is saying. This is the mid-segment of this triangle, a mid-segment of this triangle, and this is the property that you have for the mid-segment. This mid-segment is parallel to, well, this segment, DE, is parallel to segment AC. This is what you have here. And then the other property is that DE is half the distance of AC. Is what you see here, or you can look at it as 2 D's equals an AC. This is the other way of looking at this. Okay, without the fraction. Let's move on to the next slide. It says use the triangle mid-segment theorem to name parts of the figure. So for number 1, it says a mid-segment of PQR. There's more than one answer. Here it is. These are the possible answers. XY, which you see here, YZ, and XZ. Number 2, it says a segment parallel to QR. So here's QR. So you want something parallel to this side, which is going to be XZ, which is right here, this segment. Because you know that this mid-segment, by the previous theorem that you saw in the earlier slide, on the previous slide. A segment that has the same length as XZ. So here's XZ. I need a segment that is same distance as this right here. So then there's 2 answers, either QY or YR. So if this is 4, you know that this is also 4, and this is also 4. Let's move on to number 4. A segment that has half the length of PR. Here's PR. And I want a segment that has half this length, so it's going to have to be the mid-segment of PR, which is XY. So if this is, I don't know, I'll just pick a number random. If this is 20, you know that this is equal to 10. A segment that has twice the length of YZ. Where's YZ? YZ is right here. This is a segment that has twice the length of YZ. So this is YZ. This is the mid-segment of this side here. So then it's PQ. And again, if this is 2, I'm just putting a number there. You know that this is going to have to be 4. Next slide. This is a little bit long, but you should be able to follow. This is the vertices of triangle XYZ are right there. -1, 8, 9, 2, 3, -4. M and N are the midpoints of XZ and YZ. So they're somewhere over here. So let's go ahead and find the coordinates of M and N. You have to use the midpoint formula, which you saw earlier in an earlier section. So this is the midpoint of XZ, which we're going to call M. And the midpoint of YZ, which we're going to call N. So then, let's highlight that on the graph. So here's the midpoint, here's the M, and here's the midpoint N, and I connect them with the segment. Then, at this point, I'm going to show that MN is parallel to XY, so I need to use the slope formula. So MN is equal to -3/5, and you should be able to follow this without much problems. You know how to compute slope. And XY, the same thing. Therefore, since the slopes are the same, these two segments, MN and XY, are parallel. So we're done with the first part. Now let's show the second part, which is this right here. So here we go. It says let's compare the distance of MN and XY. So I'm looking at MN and XY. So I'm going to have to use the distance formula. And again, you have used this in this class and also in Algebra 1. Once you substitute the values, you get radical 34. The distance for XY, you end up with 2 radical 34. Once you simplify the radical, there's a perfect square of 4. And then at this point, you know that 2 radical 34 is equal to radical 34 if you multiply it times a half, which is what we have here. So this is why MN is parallel to XY, and also MN is equal to half of XY. We are done with number 6. It says find each measure. Find each measure. So I'm looking for angle MCD, M, measurement of angle CBD, CBD. So I'm looking for this angle here. Got a little question mark here. So I know this. I know that DF is parallel to CA. So these two lines are parallel. That's one of the properties of midsegments. So since these are parallel, this is what I want you to consider. This is going to be your transversal. And I know that measurement of CBD is equal to the measurement of BDF. Why? Because they're alternate interior angles. These are your parallel lines. This is your transversal. So then at this point, I know that CBD is equal to 26, since this is 26. This angle here is 26. Number 8, BD. I'm looking, let me get rid of this. I'm looking for BD, which is this distance. This is the midsegment of this side here. So then if this is 17, there's a relationship between 17 and BD. Here it is. So to find BD, I just need to divide 17 by 2 or multiply by half. And this is how I get 8.5 for BD. Next. It says find each measure. So now I'm looking for JL. Here's JL, this distance, and I know that this is the midsegment of JL, which is PN. So then I know that JL is equal to twice PN. That's why JL is 72. Number 10, I'm looking for PM, which is right here. I know this is the midsegment of this side of the triangle, LK. So this is the relationship that I have. So to find PM, all I need to do is divide 97 by 2 or multiply by half. And this I get 48.5. Number 11, I'm looking for the measurement of LMP, which is this angle here, LMP. Put a question mark here. This is how I'm going to do it. Again, I know that I have parallel lines. This line is parallel to this line. This line is parallel to this line. Let me highlight it. This line is parallel to this line, and this is your transversal. So use my line here. If this is 102, you know that this is also 102 because they are corresponding angles. Now, these two lines are parallel. Let me use a different color. Let me erase this. This line, excuse me, and this line are parallel. This is your transversal. These are same side interior. If this is 102, you know this is 78 because they must be supplementary. So the answer is 78 degrees for measurement of LMP. Next slide. It says triangle XYC is the mid-segment of the big triangle. What is the perimeter of the little triangle or the mid-segment triangle? So I'm looking for the distance around this triangle. Here, let me show you. How do I get 4.5? If this is 9, I know that this is the mid-segment, so it has to be half of 9. If this is 4, this has to equal this, 4. This was given to me, so all I need to do is I need to add these three values, 4.5, 4, and 3, and that's my answer. This concludes the video.